Good afternoon, everyone. We are here today for our day two on international virtual training on introduction to GIS and satellite remote sensing. We will have the same format today. It will consist of two lectures, a short break, and then the hands-on practical section. Today, we have Dr. Mohammad Zishan Ali as our resource person who will be giving the first lecture. He's a research fellow in the Department of Civil Engineering in International Islamic University, Islamabad. So, Dr. Zishan, I hand it over to you to start the first lecture of today.
Thank you so much. Thank you for the introduction. First of all, I would like to introduce myself a little bit, and further, I will be discussing regarding the theory and application of GIS, and will be entertaining some question as well. And I believe that if we can have the mutual entertainment in the lecture, so that will be much more fruitful and also the learning based process. So coming toward the point, I am Muhammad Zishan Ali. I have done my PhD from Taiwan. Currently, I am working as a research fellow in the International Islamic University, Department of Civil Engineering. Today, we will be discussing regarding some background and also some application of the GIS, that how we can apply a GIS in different fields like in multiple fields we have its application, and currently it's emerging technology, and according to the US and also the other, it's the third emerging technology in the world. So considering that, we will be discussing the application, and also I would be happy to get some questions regarding that how we can use in multiple sources and multiple way. So coming toward that, first of all, we will talk about that what is GIS and how we can use it, what basically GIS means to, and why and where and how we can utilize the information, and if we have the tabular data, so how why we need a geospatial data, geospatial information, so that those type of question will be answered in this specific 2 hour talks. And then further we will be discussing a little bit uh, about the case studies as well, that where we have used the GIS. uh, Basically, I'm trying to talk slowly because yesterday I was attending, so we feel that it would be much more better to make it understand, and also the people can get the point what I want to say or what I want to transfer my knowledge. So coming toward the geographic information system, basically whenever the knowledge is that what and where and when. So now coming to the point that what is the place, what is the thing, or what is the material, or what is everything, and where it is, where whenever you use the word where, so it means there is some geospatial information. The geographic information is basically whenever you talk about the geographic information, it means that there would be some special relation, and also there would be some defined place that where and what we are going to introduce, or what we are going to explain, and why we are going to explain. And there is also uh, I would call the when is the third dimension, which is time. So whenever you talk about the time, that is third dimension. So it's mean that, for example, if the thing is going on right now, so how we can, using the GIS information, how we can predict for the future, or how from the existing data and from the previous data, how you can calculate that this is the this would be the future, or this would be the prediction from the based of the already given information or the past information. Like for example, if I talk about the climatic change, or if I talk about the forest change, or temperature, or some other like glaciers, multiple examples there are that they are changing with the passage of time. So those type of information are needed, that from last 20 years how the pattern is going on, so then we can predict on the base of those further time period. Basically, geographic or geospatial is a synonym, and they both will be used in my further talk. And also, coming toward that, the last one, what is basically S, that sometimes we call it system science and studies. So basically, system is, I will be also explaining in my next slide that systems is a technology, that how you are using that one, how intensely or how positive you can use that, for example, like decision support system, that is, so how much you are explaining, or how much technology, or how much theory, or how much system are you using toward that you have the positive outcome from your GIS based analysis. The science is basically like the concept and the theory, or like, for example, I am doing something, so why or what I'm doing, and what is the background, and what is the concept and scientific knowledge behind what I'm doing. So now, the geographic information technologies, there are multiple data sources that can help us, that how we can use our geographic information. So basically, whenever you talk about the global, first one is the global positioning system. That is the system which is Earth orbiting satellite, which have provide a precise up to 100 meter or up to even centimeter location. So basically, whenever you talk about the geographic or geospatial information, so that the first of all, the thing coming in is the location of the area, that how location is important, and how on the basis of that location, how you can explain or how you can define your way, that where I'm going, or where we have to establish something, or how we can plan for that. So coming, the next one is remote sensing. Basically, remote sensing is our, in this workshop, we will be discussing about remote sensing data, and also further explanation in the tomorrow and day after tomorrow talk. So I will not be explaining the remote sensing today. But basically, that is the use of satellite data and aircraft to capture the information about the Earth's surface. And also some of the digital ortho images is a key product for the map accuracy. Like before, when we didn't had the satellite data, so that is basically from 70s, 1970s, the data is started from the Landsat, which is the one of the satellite which is capturing the Earth data. So that from about that, the images or the area were taken from the ortho images. That was the product, and also that was taken before that era. So geographic information system, we today we will be mostly focused at how GIS can help us to solve the different problems and different issues. So software system, basically that is a software-based system, which in, of course, whenever you talk about the system, so that will have the two inputs, and also there will be outputs, and there will be different outputs for that specific location or for that area. Now, coming toward that, what is basically GIS? So there are different map, or there are different backgrounds of that people are considering it, that this is, for example, I will be talking about the capturing the data. There are different parts of the GIS. So this is one of the examples that we are considering maps from that one, and also we can see here the map which is defined the area of, for example, this is one of the state in the United States of America. So that highlighted something which for example, we can see it that high temperature or forest fire or something like that. So that specific area, that location have some issues with that point. So now coming toward whenever you have some area, so you are doing some analysis on it. So analysis whenever we have basically whenever you talk about the data, so until and unless you get some information from the data, so the data is useless. So here it's the same, that whenever you get some data, of course we are getting some data for the GIS data input, and we need to analyze that using the GIS, and the knowledge of GIS and also our application and also our target should be very clear. So then we can use the GIS data and also further application for that specific uh, area. Like this is, for example, if I can say that this is the slope. So that slope means that this is the high area, high elevation area, and this is the steep slope. So that means that this, after the analysis and after the elevation, rate elevation model analysis, so we get some information. So that information, we should know that what information basically it is and what information we want to know. So for example, if I have a digital elevation model, which is shown the above sea level area on the Earth's surface, but if I don't know what I want to do, what I need to do, so that is basically useless. So currently, we being a beginner, we need to focus that how, for example, if I had a day, if I have a data, so how I can analyze the data that we can get some results. So that is basically the purpose, that first of all, we need to know our targets, and then we need to know, we need to get the data according to that target. So that is basically multiple apps are using as an input, and also this whenever we have outputs from the GIS, so then the decision makers are sitting there to take a decision. Basically, like in yesterday talk, Professor Shafiq was also talking about that the GIS can help us or support us to take a decision, not taking a decision. So that is also the user friendly, that it can help you to take some decision, and on the basis of that data, it can help you to take some decision. Now, GIS system science, like in my last slide, we discussed about the GIS system science and studies. So which we will do. System is basically the technology for the acquisition and the management of the special information. Now, whenever you talk about the technology for the acquisition and management, so that is basically from the step one, which is the acquisition of the data. For example, uh, uh, either we are generating our own data, or either we are taking data from somewhere else, so that after acquisition the data, the management and of the data is very important, because like we have a multiple data sets in the pre-source data. So first of all, we need to have the data set, and then we need to know that which data is required to us, and also how we can manage that data. That, for example, if we have the data which is very important for us, but we don't know which one. For example, we have a bunch of hundreds of images or hundred of data sets, but we don't know how which one data is my need and which data is important to me. So that is very important. That is basically the need of current era, that how we can introduce and how we can get that information, that if we have a bunch of data, so how we can get our targeted data, how we can get the positive data. So that is I will be sharing some literature and also some books if someone is interested, so that you can get the basic information regarding the GIS, and also further you can apply, he or she can apply it for the further analysis. Toward the science, it is basically the comprehension, the underlying conceptual issues, like we discussed in our last slide, that how science is important in the basis, on the basis of our decision making. That, for example, if we are building a road in some area where we have a forest, or where we have a river, so that need to be a background information for us. That, for example, if we are building a bridge for the river, so here we need a civil engineer for that specific work, that how he can help us or how she can help us, that it can be built on this basis, and estimation, and also multiple uh, processes will be in the time and space. So that is basically, whenever that is one of the example of infrastructure. But if we go uh, for some other analysis, like for example the forest, or for example the agriculture, which is one of the important for the Pakistan and also for the developing countries, and also the developed countries are very focusing on the agriculture area, because agriculture is one of the main output, and also export or import can help us in that perspective. So the theory and concept behind the technology is very important. So like we discussed about it, that if we, for example, being a layman, if I am a layman, so I have a lot of data, I have software, I have everything, but don't have the concept and don't have the background knowledge, that how I can use the GIS, or how I can use the get the information out of the data. So that is basically very important for us, that how we can use that data in a positive way, that we can get the result which we are targeted or which we needed. So introduce enough of the science to apply the systems correctly and understand their capabilities and limitations. So now, whenever we have a data, we have information, so we have software. So now we have to know about that, how we can apply that on the system correctly, and also understand the limitations and capabilities, that how it is important, and how, which thing is important for us to know about the overall scenario. Or for example, if I'm predicting something, I am applying something, so how it is important for my knowledge, or for the future, where I am giving this decision to policymakers on the government authorities. So how much I am reliable, how much limitations are there. For example, if I predict something, that a road will be constructed on the base of the mountainous area. So how much, which are the limitations? Like, for example, if we talk about the landslides, or if we talk about the rock avalanche, so those type of limitations should be known, that I am giving you the suggestion, but those are also the problems that can be faced during that work. So both ways, that then after those outputs, the authorities will be decided that either we need to take that risk, or for example, considering that limitations and also the capabilities of any work is important or not important. So that is the overall structure. Now, studies the understanding the social, legal, and ethical issues associated with the application of GIS and GIC. So that is basic. That is just some examples in the area, that where we have some of the specific application of GIS in the area, that how we can employ the GIS information on the basis of that specific information, that how it will be helpful on the social basis, or for example, if we are getting some data, on the tabular data, that legality or ethical issues. Like ethical issues is also very important for the data set, because some of the data is uh, very uh, very confidential, so we cannot use that without taking the permission, because that is not legal at all if you use someone data. So that is also some few things that is it's important to be considered. um, the history, we will be discussing about the history, that how GIS history is geographic techniques were before, that was using by cartographer, that was uh, mapping on the basis of hands, and also some different techniques. Yeah, like if we talk about the traditional geographic way, that we need to some types within the map, and then cartographers are drawing that map. So that was before era of 1960. So after that, the first GIS was introduced after 1960s and operational from 1971. A USA government organization, that is USGS, and US Forest Survey, and other, including the CIA, that is using, that was the first in the 1970s, which were using the GIS for their application, different application in that. Within the academia, Edinburgh, they have basically developed some softwares and then stored it in 1973, and also the Harvard, they have developed in computer graphic, and also the special analysis lab in 1965. So that was the important turnover, that how the cartography is digitalized toward the GIS and more GIS at that time. Sorry, so the remote sensing was afterward. So that is important, that how computer graphic and also the special analysis lab were developed, and also after that the era was completely changed, and now the GIS is just like using everywhere, in the even in the government organization, and also the non-profit organization, like private industries, and also like organization like disaster management, and also other application. I will be talking about application in the next slides as well, but just giving the overview, that how the background of GIS was started. So after that, the ESRI in 1969, the environmental consultancy, they have developed a software which is ArcInfo in 1982, and ArcView, and also in 1995, and also after that, the ArcGIS, which was the first version in 1999, was also developed by the Azure, which is currently going on, and the publisher and also the copyrights is still with the Azure, and then they are updating the software, and currently they have the new version. I think it's 10.9 up till now. Uh, Considering the physics and space, moon landings later, CAD utilities, and laser scan, intergraph in 1969, and demographic consultancy map info, that was 1986. Those were different organizations which were using the GIS with the passage of time. Open source, gross, quantum GIS, and also those are the different links toward the uh, database management system. So that type of softwares are using basically for the data management system, and that is helping us to further evaluate, and to further elaborate the data set, and also give us the in the output in a proper way, positive way. And WebGIS is further currently multiple people are using it in the different WMS management system, web management system, WFS, and Google Map is using it, Google Earth, and also OpenStreetMap. So those are the different publisher and different geographical location based operation are using in current era. So if you talk about the Google Map or some other OpenStreetMap, which is helping nowadays the layman, like in for example, if I talk about within the country, in the capital of Islamabad, so the some Kareem or other taxi services are using that. So that is basically whenever you send them a location. So on the basis of that location and on the basis of the uh, given data in the Google Maps, so that is basically locating the nearest point and also the route for the location, which I will be discussing in the case study as well, that how they can considering the route, the best route for the Google Map or for the area. Now, function of GIS are basically uh, that is used for uh, on the basis of different function on the basis of different time. We have different parts of the data set. So, like first of all, the data acquisition is important. Like we discussed that if we don't have the data set, uh, we cannot do anything, right? So the data acquisition and pre-processing is the first step for any geographical or any type of data. So first of all, we need to know and we need data set. So that include, for example, elevation data, hydrology data, which is the, for example, the water body, and also the transportation, soil, geology, ownership, site data, and also the imagery. So that type of data set, whenever we have that type of data set, we have uh, we could further analyze the data and we can assess the different information from it. So those type, whenever we combine those type of data, like we have multiple layers in it, so we can combine the different data set in it, from those layers. We overlay it in the GIS softwares, and then we can get some further information from it, that uh, we can how we can collect the data. For example, if I talk about here the database management and retrieval. So now this is the different data set, and this is the data set management, database management. So first we need to target that which type of data is needed and which type of information I need from that specific data. So that are the 2 points where we need to know and what our target. So data storage is one of the main important parts. That some data is stored such as maps or drive, while other are such as digital data. So that is one of the main thing. Like we can see here that there are raster data, which is discussed yesterday, and I will be discussing today as well. That we are combining the raster data, which is the imagery is basically the raster data, and further we have some vector data set. So vector and raster is combining and give us and put it in the data management system. And after the data management system, it's giving us the output data set, that how how the data was evaluated, and we have done some, for example, like that data was input, airports, elevation, and some lakes, and some different types of data was input, and then we can get special measurement analysis. That, for example, if I given that that much data as an input to the GIS software, and we have done some analysis on the basis of that one. So how the spatial measurement analysis were done on the basis of space. Like, for example, the input, the spatial measurement analysis might be for example, the heat map, or might be, for example, the some disease in the area. So if we have all the information and we give it to the software of GIS, so we can get some output. And then once we have the output, we need to have we have done the multiple queries. Like in GIS information, the data query is very important. That how we can, which information we needed, right, and which query we are giving. If I am giving a query that, okay, I need some information where I don't have a lake, I am near to road for example, 5 meter, and I am near to airport up to 10 kilometer or 15 kilometer, and I should be near to park for 2 kilometer or something like that. So those are different queries on the basis of that data set which we have. So considering that data set, considering your query, it will give you output as a result that according to your query, this is your output. And here, for example, you want to build your house, or you want to give some specific location for the school or something like that. So that query will be aligned on the basis of that. And after the query, we will have the visualization, the graphic outputs and visualization for that one. So once we have done the query and analysis, and then we will be using a uh, different types of visualization, which will be easy for multiple people, that how they are considering it and how they can utilize that information for the specific area, for the specific location. So that is basically uh, important for us to know that which area and which location is very important for that specific task. Or like, for example, if I am talking about the school, or for example, the house for the building, and some other locality or some other point of view. So that is visualization, or we can consider it map or some other outputs, which can be understood by policymakers, and also it should be explainable by the GIS user, that on the which basis that specific map was generated, and which is the information given, and that given in that specific map. Uh, Now we will take a short break for the question answer session. I think we can have step by step plus question answer sessions, so that would be easy for to make it to mind, and also it would be easy for you guys to have behind back and me as well, that you are going with me or not. So welcome some question answers, and then we will be go further for the furthermore for the topic. Uh, don't have a question? Okay. So uh, can I get some hand raise? because I'm not, I cannot see the question from around 50 people, or that only me, or an issue with that.
Are you waiting for questions, Dr. Zishan?
Yes, I am actually waiting, but I think there is no question, right?
For participants, if you have any questions, just drop them in the chat, and then in the
Okay,
question time, Dr. Zishan will have a look at the chat and answer all the questions there.
yeah, sure, sure. Okay, so going further, for the geographic information system, a map with the database behind it can explain that how the GIS and how the geographic information system is very important for us, and how we can help the policymakers and the other people that for the representation and for the issuance of the outputs maps. So different, the visual representation of the real world and its infrastructure is very important, because whenever we have a virtual output for the real world, and then we can plan something for the on the basis of that virtual information, we can explain, or we can plan something for the real world as a consisting as a build-up of a real-world natural and man-made, which is queried to support ongoing operation and also summarized to support a strategic decision making and also policy formulation. So that's what I have explained in the last slide as well, and currently that how uh, considering those different layers, how we can get some information which can be used further for the considering that specific planning, or for the policy makers, that how we can consider or how we can positive utilize our knowledge which was based on the GIS information, and it can be helpful for the policymakers and also the government-based organizations that can be utilized further for the knowledge. Uh, Now, how GIS differ from the other system? Uh, First of all, it's about database management system, that is typically MIS, that is Management Information System. Basically, the database contain every but not explicit locational information. That is basically one of the main thing, like I was discussing during from the last few slides, that how the main thing, like before GIS, the management system or some other database IT information, that is also considerable. But whenever you talk about the location, so then we need to use a GIS, basically, because GIS is first give you a location, and also on the basis of location that have connected the database behind it, that we call it attribute for the area. So I will be explaining the attribute in the next slide as well. So basically, whenever we have the locational data, that might be a city, that might be a county, zip code, etc. But should be it should be have geographic coordinates for that specific area. So that one is, for example, in 100 north and high around the corner of across the town from the 200 feet, which is the east main. So that 2 points are using basically on the basis of only location. So automated mapping, that is, for example, thematic mapping or some other the Coral Draw, ArcMap, sorry, some other point, the paint-based mapping, and some other. There are very luxurious mapping softwares, even unpaid and paid. But the thing is that how we can use the geographic location and also which is database within that. So if, for example, we are only generating the maps based on without the coordinates, that is also uh, for me, being a GIS person, that would not be enough to be utilized in the real ground. But on the other side, if we have the database management system, which is MIS, so that don't have the location map, so that is also not enough. So considering those type of issues, the GIS is the best way which can help us to location and also the tabular data to combine it and to use it and to also connect the database with the background and also give on the basis of that location. So that is basically the data source. For example, if we have the street data, those are the data layers. We call it multiple layers. Like, for example, first layer is street data. That is, those are the streets, and then we have a building data. So one by one, those different layers are connecting, and then we have vegetation data, and then we have integrated all the layer, that is called also the overlay. So that is shown that integration of all the three layers, which are different layers, but actually on the real ground, that is this is the real ground where we have the vegetation also, where we have the settlement also, and where we have the street or also water bodies or something like that. But whenever we talk about the GIS, so it gives us different layers, independent layers, which we uh, combine the different layers and also then give us some output, and we consider it the we consider it as a whole overall output for the specific location. The more first we were talking about the GIS and its mapping and layers, different layers. Now we are talking about the modeling with GIS, that how we can model something. For example, if we have the layers, different layers, and then we want to model on the base of that specific layers or the on the base of the existing data, how we can model something for the future, or how we can model something on the basis of that data. So conceptual models to understand the world predict the conditions at the location in time or space. Uh, like in my start slides, I have discussed about the conceptual model, that how we can understand the world. For example, uh, I am talking about the northern area of Pakistan where we have a lot of glaciers. So if I consider the data from the 2000 onward 2022, so the data shows the pattern would be the declining of glacier. So considering that one with the passage of space and time, so it shows that it is declining if the temperature is same for the area. So how we can model those type of things, that if the consequences are same, if the temperature is same, the temperature is increasing and the glacier is decreasing, so what would be the consequences, how we can model it with the passage of time. So that is one of the beauty of GIS, that we can notify it the modeling with the GIS using different tools. There are different models like mathematical models, within mathematical models, numerical models are used, and also formalized, some idealized, some less so. Now, the numerical models, either it have I mean, the optimization of the model is very important. Within that specific line, we can consider it that how optimized our model is. For example, we have modeled something where we considering that here the slope or the something else is at this scale, the slope is steep, and some other problem or some other formulation is there, and we need to optimize and we need to consider that one on the basis of that specific area and that specific location. So that is very important, that how you can formulate or how you can analyze the thing that that should be according to the optimized outputs, and it should not be overestimated nor neither be underestimated. So the optimization is very important for modeling in the GIS. Anywhere in or whenever you are predicting something, optimization is very important. But considering the same rules, so if we talk about the GIS, that is also apply the rules here as well. The data models, that is structure and also the flow of information in time and space. So now I myself have done some studies which might be I will be discussing in my next talk as well, uh, and that is regarding the water resources. So we have done some studies regarding considering the GIS based analysis, and also we have considered the space, how the space pattern is changing, and how with the passage of time that space and time is changing. Now consider the example of for example, in Islamabad or within Islamabad, I can consider uh, the Islamic University, International Islamic University. That, for example, if I am saying that the temperature or humidity or some other parameter that is increasing, uh, increasing here, but if I go toward the mountainous area, that the temperature is decreasing, right? So that means that with the passage of space, the things are changing, right? And with that specific area, if we consider the time, so it means there in the mountainous area, the temperature will be increasing with the passage of time, like due to climate change. So that is important, that how we are considering that specific location, that area is increasing, how much with the passage of time and with the passage of space, how much things are changing. So that model are predict on the basis of both the time domain and also the x and y coordinate, that is space. The spatial data often not always represented in the map. Uh, Data with the special component, some attempt to be addressed to time as well. So that is uh, important, that how we can consider that that data for the specific area is how much important and also represent with a different map. Like if we consider that for different years, different maps are considered, right? So that shows that how much, for example, annual based mapping, so how much uh, area or how much, for example, quantification of anything in that specific location, and also how it can be changed from one location to another with the passage of time and with the space. So that identification and that changing pattern need to be identified and also need to be highlighted by different policymaker, that For example, the ground. If I talk about the groundwater withdrawal, so in that the central Punjab area as is considering the high groundwater withdrawal from the area from within the Pakistan. So now if I'm sitting in Islamabad and I'm talking about the central Punjab or southern Punjab, so that is basically I'm talking on the basis of that specific location based data or some other remote sensing based data that can help us to notify or to highlight that specific location that in this area with the passage of time the groundwater is decreasing uh, or either increasing in some way. So the computerized spatial data, that is quick space analysis over the wide extent. Uh, Basically, whenever you talk about the point-based data, that is explain only the only one point, only one area. For example, if I am talking about the observational well, or although the observational well is something different, but if I'm talking about the temperature or humidity or some other variables of climatic uh, variables, so that is of course that is not only for specific location, because in that surrounding area the things would be seen, but in some variable where we only have a point, so then we need to have the GIS based analysis which can help us to spread the overall information within the different area where we don't have the point data. It can help us to spread the information and also give us the analysis where also give us the output results where we don't have the point data. So that is the helpful for one way. Now coming toward the GIS system architecture, uh, that one is basically the component which we are talking about is the input query. First of all, we are talking about the data input and also geographic database, uh, which is the important, of course, that whenever you have a database that is basically working on the different parameters on the different layers, so that database can help us that how formulations can be taken, how it will be helpful for the overall utilization of the data. So first of all, we have all the database, geographic database that include a different layers, and after that we will have a different queries. So now, whenever we have input of queries, we need to send the information of queries to the geographic database. That okay, I have a lot of data, but I need this information. Like if we talk about the specific location or specific, for example, if a road network, I have a database of road network and also the streams and also lake, some other. So if I am giving a query to identify the road where we don't have the bridges, I mean, don't have the about the river road. So that geographic database will search it and give us the output, transfer of information of analysis, and also give the output analysis. So that is basically overall scenario. Sometimes we directly get the output and display, and then we transformation and analysis of the query is sometimes it's very important. So then after that one, we need to display the result, and which can help us to motivate or to develop some decision on the base of that query. Now, I will give some short example of, for example, we can see about the electricity meter or some other, even nowadays, the GIS can be used in different areas, like if we talk about the electricity or some other meters or some pipelines, so that all the data can be saved or can be database can be generated based on the using the GIS, that how it can helpful for the GIS and for the overall area, that it can help that where the main pipeline or where the semi pipeline are going on. So those type of database, I'm just talking of one example and very small example that shows the importance and that shows the application of the GIS within that area. Now, coming toward that, uh, the knowledge base for the GIS, that is, we have a different inputs for that to make it a GIS. First of all, if we talk about the computer science, that is management information system, as we talk about that why GIS is important. So considering that one, the GIS, like if we talk about this one, that this is the computer science and MIS management information system that shows us the graphics visualization, which is an important key of for the GIS database system administration security. But the thing is that location is very important for us, because if we don't have the location, so then that would not consider as a GIS. So now coming here about the geography and related cartography, like I discussed in my start slides, that how the geographic, the GIS was using before as a within the by hand mapping using the cartography. So that is important, the geodesy and although photogrammetry, landform and spatial statistics. So that is also the main part, and also the application areas. For example, if I am talking about only the geography cannot consider the GIS based knowledge, because we need to have the information. We need a special location, right? But we also need information, that is the management information system based on that location. But after, whenever we have both the data set, for example, I have a layers, I have a different data set, and then I need to have some target for that, that how, what I am going to do. Or for example, I am planning for something, urban planning, geology, mineral exploration, forestry, site location, and also I will be discussing that all the applications within the next slides with the step-by-step process. But here, just wanted to give you an overview that how we can get the how from the different merges, how we are calculating the GIS, that okay, if we have a computer science information like MIS management information system, and we have the geography related information, location based information, and then we need to have some target and also some application for that. So that combining of that, those three, that will consider it as a geographic information system, where we can apply it on the different applications for that specific location. Now I'm going to take some questions. I will be happy to get some questions from audience.
Mohammed, you may ask your question now. You raised your hand.
You may talk, please.
Mohammed, you raise your hand.
Hello, very good day, please.
Mhm.
My name is Mohammed Baba Adamu, and I am from Nigeria, working with Yobe State University, Department of Geography. My question goes to the presenter, sir. I have
Yes, please.
interest in, hello, sir, are you with me?
Yes, yes, I can hear you.
Hello, sir. Fine. I am interested, though I am a beginner in this field of study, but I would like to apply GIS in studying or monitoring sand dunes migration and its impact on land use and land cover. I will be happy if you can give a bit background as to how I can achieve this, or how I can apply this GIS-based knowledge in monitoring the sand dunes migration and its impact on land use and land cover. So thank you very much.
Sorry, I cannot get which information for land use, land cover.
What I'm saying, sir, I have interest in monitoring sand dunes migration or sand
Sand
dunes
dunes migration.
advancement on, yes, sand dunes migration, the impact of sand dunes migration on land use and land cover. And I will be happy if you can lay more emphasis on that, because I'm a beginner in GIS and I have interest in applying GIS in monitoring sand dunes migration and its impact on land uses. I
Sorry,
don't
I
know if you
cannot
have gotten the
understand
question
your
well.
word. The sand use migration. What is that one specifically?
Yes. Hello, sir.
Yes, I can get you, but the thing is that sand dunes. Okay. Uh, Basically, whenever you talk about those those type of migrations, like for example,
Yes, sir.
sand dunes or some other that have first of all, that should be you need to get some information on the basis of the imagery, like GIS remote sensing images, which is basically from Landsat and from Sentinel-2. That type of data is also available.
Okay.
So on the basis of that
Okay.
data, it can give you a specific real-time location, and also from the existing, like for example, if I talk about the Sentinel data, that is available from the 2014. But if I talk about 16, and then if you talk about the Landsat data, that is available from 1970s. So that is basically important, that how from the existing data, how it can how you can find the land cover impact on the that specific areas, that how it can, how it's impacting on on that area, and how land cover is changing with that specific, for example, like vegetation is removed, vegetation is increased or removed, or declined, or some other, like habitat or changing their locations, and also some other point. So those type of things
Okay.
are need to be identified within specific area. So considering that one,
Okay.
whenever you need to map those type, you want to see the impact, or you need to see the land cover change just because of the desert features. So that is basically, you need to take some images from the last few years, that how much it's changing from the one. For example, if you want to see the land cover impact, so okay, so if you think that it is very for the long term, so you can consider the time period or the image from the 2000 or even 1990. So then you can see the overall change pattern for the time period. If you think that it is not it is short period, so then you can take the annual. So that is basically that's why I'm asking that the knowledge is very important, that how you can get that specific to achieve your outputs, that how you can get your for example, yeah, like you are talking about the land cover change. So that is important, that you need to know that which things you are going to do, and land cover change for example 50 20 years or 5 years or how much. That is important. Thank you.
Thank you very much. Thank you very much. Thank you very much.
Most welcome.
Are you Boardroom? You may ask your question.
Assalamu alaikum.
Walaikum assalam.
My name is God Jamal from the Department of Geography, Islamic. I'm actually in the first session when you first raised the whether there are questions, but we had the internet challenge here and there. However, nevertheless, I'm going to ask this in this session: how can GIS be used to segregate information that is legal for public and that is not legal for public?
You're talking about the GIS information, right?
Yes.
Basically, like we discussed about the information which we were talking about, that legalization, or for example, if we have a confidential data, like sometimes we are taking a data which was the government-based data. So that is important to get the information from it, but you cannot share the information. So on that basis, I was talking about the legalization. So for example, if I have some open source data that can be discussed, that can be gone anywhere, it can be shared with anyone. But the thing is that some of the data which is taken from the different organizations, so that cannot be shared, or that cannot be distributed within the different people. So on that basis, I was talking about the legalization and also the uh, ethics of the data set and also the GIS information, because that is basically the space-based location. And we know that different locations are very important for some, for example, for some activities. So they, if we talk about the defense-based activity, if we talk about for example, some organizations that don't want to share their information. So that on that basis, I was talking about the legalization and also the ethics of the data set.
Thank you very much.
Thank you so much. Thanks for your question.
There are some questions in the chat. There's one that says, how can GIS be used in public administration? Dr. Zishan?
Yes.
There's one question in the chat.
I cannot see question. It's maybe
Send it to me. I'll
towards
read
you.
it out for you. I'll read it out.
Yeah, sure.
How can GIS be used in public administration?
Okay. I'm by the way, I'm coming toward the application of GIS in the in next slides. But in the public sector, like we are talking about, if even the information, for example, a public sector. If I take an example of the police or some universities, professors or some other, that information, whenever you talk about your government-based vehicle or some specific people, so that is important to know about the location, and also public administration is important, that how we can manage things within the specific location or within the specific area for the specific people. So bunch of people, for the bunch of different people, if we explain it that in that way, that for example, that specific people need to go there and then work there, and then it is a tracking system. Like currently we different people are using the tracking system for the government. In the government organization, we have on the vehicle, we have a tracking system. That is one of the use of GIS. And also some other, like people are using it for the different perspective. So that type of usage. And also currently it's even in the police sector, they are using for the crime based mapping. So the high red spotted area, where a lot of crimes are inducted in the area. So for example, the mainly the area would be highlighted, and also the different police patrol or going there, patrolling there in the area. So that I mean to say that now this is one of the small example, the crime based mapping or the hotspot analysis of crime in the area. And also if we talk about the forest department or wildlife department or some other departments. So in almost in mostly in every department currently GIS is needed, or also the land revenue generation, land revenue department, that is one of the important. And also the some other. So currently GIS is the main cause for almost most of the department. I would not say all the department, but at least most of the department need to go through the pattern of GIS, and further use the remote sensing data as well.
There is another question. It says, is there any difference between geographic information system and geographic information science?
Basically, that is using in the mutual way, because whenever you are using the GIS, geographic information system, so of course you need to know the knowledge. You need to have the knowledge of GIS and the science, background science. For example, if I'm mapping something, I'm working on something, so of course I need to know the background, the concept, the theory of that specific work I am doing, the task I am doing. So that is basically, you can use it simultaneously, that the science behind the GIS is important, right? So whenever you are talking about the information you need from GIS based analysis or GIS based work, so that is important to know the background, and also the results you got from your analysis is important to publish or to present in somewhere, or to define, explain it in the form of maps. So that is important as well.
So we'll take the last question, which is, sir, may you elaborate more on visualization database?
Visualization. Basically, visualization is like just a few seconds ago, I have discussed about the visualization, that how in a better way you can visualize something. So that means that if I have done some work, if I have done some analysis, how better I can visualize, or how better I can map that one. So that is, visualization is basically the display of the result. So how better I can explain, for example, I am doing a hotspot analysis or some other analysis. I will be showing some maps as well in my next slides, where we can see that how visualization is important for that specific area. So that one is important for the specific location, and also for specific area. Can we get some other question later on, because I have a lot of material and I don't have a time.
continue with your lecture, and you can take questions right at the end now.
Yeah, sure. Thank you so much.
Thank you.
So after the talk, that specific ongoing talk, we will take the question at the end of the talk. So please, if someone have a question, please put it on the chat, or also you can write it with yourself, because after that we will be stop after the end of the talk. Thank you so much. Different data types we have in the current GIS and remote sensing, like vector data type, that is point, lines, and polygons, and also the raster data type, which is the cell, pixel, or element, which is defined in the area. Coming toward the attributes, which we were discussing before as well, that attribute is basically, you can ask, you can say the management system, management information system, you can call it that. That is basically MIS of the GIS. So one is the visualization, right? Location-based analysis, and every location consider its database that is within saved in the attribute. So that is vector multiple attribute properties. So for example, if I talk about the point data, there might be a multiple attribute for that specific point data. I can say that, okay, this is the parameter, this is the point where I have the the monitoring data, monitoring station for the climatic change. That is, for example, it's calculating the temperature, also the humidity, also precipitation and depth. So that one point, considering the different attributes within the attribute table, that how much attribute can be considered within that specific point. So is the line feature, for example, the road network, the length of the road, either it's primary, secondary, or highway or motorway. So that types of its feature can be saved in the attribute table. For the raster, the single attribute value, that is its binary number or pH values. Each cell have a different values, and this at the attribute. So every single layer have a different values for the specific location, but can also have in term of the attributes when you attribute. So one might be the we can also explain it with the passage of, for example, one is acidic, 7 is neutral, and alkaline, 14. But again, it's only one per value. So now the point is that, for example, if I have multiple lines or multiple points, so then one road is primary, second is secondary, and one is motorway, and one is highway, and another is secondary. So I have multiple roads at that specific location, but every road might be, there might be a same attribute, like for example, in one location, if I'm mapping some roads, so there might be, for example, 10 or 15 secondary roads. So it doesn't mean that it should be same. There will be some location difference. There will be some other difference. So there is always different attributes where we have a different values within for the specific, I have a set of 3 to Can you hear me?
Yes, you're audible and we can see the screen.
Okay, sorry for the interruption. Okay, so file format is basically uh, I have discussed about the shapefile, and also now geodatabase is we are discussing about the geodatabase, that is a single file and the operating system level neatly hold a vector or raster data set that basically have the backend the data backend of the data set, which calculate the overall geodatabase for our whole software backup. So what type of work we are doing, that is basically saved in the geodatabase set, that can help us further later on to use it for utilization of file. Coverage, that is vector and also the grid raster. Older format you may use need to know about it. Basically, the grids are also used as a raster format and also used in different raster data set, that is in different formats, like GRACE data is also in the grid format, so we need to change it in the ArcGIS software and then also in the some other software. Some examples of the special data, that is basically the road network, vegetation inventories, soil inventories, consensus, results, municipal boundaries, elevation values, climate reading, and habitat ranges. So that basically whenever we develop our own special database, so that is one of the way that, for example, if I am talking about the road network, so uh, that is basically that a road network can be developed by from the Google Map or from some other sources, or if we have some images, so we can develop our data set by our own sets that can be developed from the image or from other source using the ArcGIS software. And also the vegetation inventories, soil inventories, and also consensus of results, uh, and different data set can be developed using the GIS and also by the help of remote sensing. One of the factor in the GIS is also the map scales, so that how scales are needed for the map. For example, like we talk about that why GIS important, why GIS is important. So if we talk about the Coral Draw or some other software that can develop very beautiful map, but the thing is that again, if we don't have the scale or if we don't have the coordinates, so that is basically just a picture, right? So if we consider it a map, so that should have a scale and also should have the also have the coordinates of the area. So basically, we usually have the fractional scale, which is, for example, 1:24,000 or 1:62 500 etc. So that ratio of map world to real world in the same unit. So now the thing is that this fractional scale show that on the map, for example, if I consider it as a inches, 1 inch or 1 centimeter, so that should also be a that much centimeter. So if I consider that on the map, 1 centimeter is considering on the ground 24,000 centimeter, which is on 24 meter. So uh, that is basically, sorry, 2400. So and 240,000 feet. So basically, on the both side, that fractional basically means that on the both side, the unit should be same. So that is also the same unit. So a scale bar is a regular that convert the tile map distance to the real world distance. So that is just like you can see the 1 mile, and we can consider it on the map. Large scale maps shows a small area, and a small scale map shows a large area. That is basically that whenever we are considering, for example, if I can say that, okay, 1 centimeter on the map should consider 100 miles area on the ground. So that would be a small scale map. Basically, that means that on the map, that is the area is very small, which is on the real ground, it's very big. But if we talk about that, for example, uh, on the scale on the map or on the image, we have a small area, but on the real ground, it's also small, for example, 100 feet or something like that. That is very identifiable very easy. Uh, because of the fractional representation of the real world, that one is larger fraction than this one. So of course, that this map shows a smaller area at a high level of detail and resolution. That shows that on the real ground, that much area is considered according to the on the map in the 1 centimeter or 1 inch. Scale issues are coming in the different GIS users. So like if we talk about in this example, so the state boundaries drawn to cover the entire state was collected at much smaller scale than voting district. So here we can see that how much that specific area is highlighted or how much this one area is. So that scale issues are very important or need to be highlighted within the area whenever you're talking about the scale or whenever you're talking about the mapping or generating the data set. So if you don't have the proper data set, so then it will be not be easy to develop good research. Issues with the data, collect too much data and box down to the machine trying to display the data too little. Like whenever you are collecting the point data, so if we collect too much data, it would be very precise, but it will be very computationally expensive. But on another hand, we don't need to take a very little bit of a data which is not accurate enough to show the overall scenario. For example, if I am talking about that, okay, I am mapping the road, so that is not the real representation of road. Map types, different demands require different types of maps. Dependent on the data being used, different maps can have many symbols or any one symbols. So depend on what type of you are trying to show. That is basically, for example, now I will be showing a different just to show you, to visualize you the different types of map, that how we are showing the maps in the area. So now this is one of the example that the single symbol map that is just only showing the state boundaries within the area, and all the area is shaded with the pink, and but we have the state boundaries identified within the whole United States of America. Now, categorical data, which is usually we are talking about the legends of the area. So that is the points or lines or polygon. So that is basically a different type of data set, which we usually categorical data, and we have put it on the maps in the area. That is one of the example of geological map, that how the different layer are represented in the different area, that how it can be differentiated from one another. So those basically those layers are generated in the ArcGIS using the shapefile and vector and some area. Those are some of the classified maps. Now, like I think there was some question regarding the identification of map. So that is basically different class maps are there. So that shows that how much of classes or how much it might be the state capitals population. Like here, it's a population. So now we can say that this population is identified in this specific area in every state. So we have a different population in a different interval. So that shows that, okay, if the population will be within between those two numbers, so the number would be that much. So it shows overall pattern and give the overview of the population. Like we can see here that here it's a big here, and it's also the state capital. If we just digitalize our map unclassified, we didn't find the classes, so it would be like 10, 10,000, 100,000, and 1,000 and 1,000. So this one is different, and this one is different. So if we have more classes, so it would be distribution would be uh, much more easy to show. That is one of the color map which shows two variety of precipitation map using a color intensity. So now the thing is, those type of we usually sometimes call it heat maps, or sometimes it's using in temperature and also precipitation and also some of the different utilization where we have the changes with the passage of space and time. So at those type of maps shows us that where we have a very high intensity of, for example, precipitation or temperature or something like that. So that shows that here, for example, those are precipitation maps. So here we have a very high precipitation and goes on with the low. So those type of maps shows us that how much it is and the area have a high precipitation. So that area, the bottom is the two-toned color ramped with the same data with the yellow, dry, and green better. That is basically the yellow is dry and the green is wetter. So that shows that higher toward lower in the area. And that is the dot intensity map. Can be normalized the data by letting each dot represent 1 million people in the area. So that shows that within the different states, we can see that this is a very high intensity population area and this one, but in central and northern USA, we can see here a very low population in the area. So that shows basically if we don't have even the overall population number, but still we can, if we can identify that, okay, we need to put a point if the area having a population of 1 million. So that also give you an example that where we have a high population or where we have a high density of population in the area. We can also develop the chart maps of the which can be represent the several attributes such as the proportion of ethnic groups, and also that pie chart can show us that, okay, where we have like we can see here the difference of the maps, that where we have a different ethnic people in the states. We can see where we have only the single ethnic and also some of the half, and we can see here from this one we can say that, okay, here we have a different uh, versatile people within living in these states, and here we can see. So that shows, basically that is the beauty of GIS, that it shows us the overall scenario within the map. So visualization is the best way to show the result within some area. So if I can show this map to anyone having this attribute, so he can understand that what does it mean actually, that what he want to say or what he want to show. That is the classification interval maps for the area. uh, that is basically natural breaks or some different distribution are shown in the area for specific interval. So that we can see here that it have a different special it have a different distribution, interval distribution, and it shows us that where we have a very high or very low or moderate or something like that. So that shows that how GIS can map or can give us an example for that specific location and that specific area, that how it can be highlighted or identified in the area. Now coming toward the why study GIS, 80% of the local government activities estimated to be geographically based, like plates, zoning, public work, streets, water, like we have garbage, and different usage of the GIS in the area. So now we can talk about the state government. If we talk about the state government, so the geographical component is the natural resource management and also the highways and transportation. Within the business, we can talk about the GIS variety or retail sites, selections, and customer analysis, and then the natural resource exploration, that is petroleum, and also the civil engineering constructions, military defense, and also the scientific research employs in the GIS and geography, geology, botany, anthropology, and also some other epidemiology and criminology as well. Like I have given one of the example, like the public. One of the question was like regarding the public office users. So that is one of the example of criminology, that is even in some main areas where we have a lab specifically for the to mapping of criminology, to have the knowledge of criminology, and it can be used using the GIS map. Application of GIS are in agriculture, urban and town planning, and also oil spill and GIS in business marketing, like I have discussed, vegetation management, dam site selection, and also mapping and navigation and disaster management. Uh, in country, in northern area like Gilgit-Baltistan and Chitral, and also the other area, Muzaffarabad, and also like other attached area. So that areas have a lot of disasters, like landslide, and it blocked roads and transportation network has been cut off. So that is basically for specific those type of problems, GIS can be used, and also disaster management is one of the key important role for in the country as well. This is basically the application of GIS in different fields we have explored already, and also we can see here the urban planning, management, and policy, like zonations of subdivision planning. Like we have some administrative boundaries, uh, like districts, and also then we have some divisions, and also some provinces, and then we have a country union council as well at a downscale level. So those type of zonation can help and can be used using a GIS, because if we talk about zonation and also the database of that zonation is important. For example, if I have developed a shapefile of district, So the district name, the police lines, and the schools, and everything should be within the database of that. So that is basically the application of GIS in the area. Land acquisition, like currently, I think in Punjab and also in KP, land acquisition and land revenue department have their GIS relevant people in the offices, so that they can help them to digitize all the land and digitalize the database of their, which is which is before it was with the Patwaris and some others, but currently they are trying to digitalize everything so that they can get properly revenue from that. Economic development, reinforcement, code reinforcement, housing. And if we talk about the environmental science, the monitoring of environmental risk, modeling, stormwater runoff, and also the environmental impact analysis, hazardous or toxic facility citing, and also political science and those type of different areas. Application of GIS and disaster management, we can see here the hotspot of the area, and overall we can see the different management of the how it can be managed using the GIS, that different layers and different areas can be combined. For example, this is if it's a storm, or if it's some map which is this is area is highlighted, so that can be generated or that can be developed by the area. Application in the forest management, we need to know about forest management and its application for the GIS, because mapping of forest is very important, and even it can be with the current studies and with the current technology, even you can map single tree as well using LiDAR technology. So that is very important for us as well. Urban planning, that is one of the application which is currently, like, we have a lot of deforestation, and urbanization is increasing day by day in worldwide, not only in Pakistan, but also in developing countries and developed countries. So that is one of the important issue and need to be discussed by using the GIS. Application of GIS in agriculture, that is also currently PCRWR is also working on it. So they are basically trying to utilize the less water with a high utilize the less water but get a high number of yield from the wheat or some other. So that type of analysis can be done using the GPS based data and also the GIS and also the precipitation data, so that type of data can be used. Application of GIS in different field like businesses, education, administration, and real estate, and also the healthcare epidemiology like need analysis, and also the service inventory. The healthcare I have is some example in the last slides as well in the case studies, so that will be discussed over there. GIS in current academic institutions is for the renewable resource management, forestry, and biology ecology, which is the and geography, and also the earth and atmospheric scenarios, that is including the environmental sciences and also the geology. What GIS application do basically manage, analyze, communicate. So those type of all the routing and all the analyzation of the data, and also giving us the output, so then we can get results in the way. That is GIS overlay, one of the example of that, how the case study can be developed or how the case study can be explained. We have some overlay of GIS, what resident live we need, this toxic deployment of ammonia. So that is basically, for example, this area specifically have some issues with the high concentration of that specific area, very high, and then it's extremely high area. So that concentration is of anything that is toxic currently, but it might be anything, any other disease or any other emergency based, which like we can say the virus or some anything else that can be it's covering under the way of epidemiology. So that is basically important to know that how it can be mapped and how it can be, for example, if I have this map and I need to give it to the media that this area is very dangerous according to that specific, for example, virus or some toxic form. So that can help us uh, to mitigate the people from the different areas. That is basically the point trial in the different elevation area, so that we can have the different elevation and also the uh, this this area have a different elevation zone. How we can, for example, if we want to go in this track, so how we can, how the elevation can help, and how uh, like this road is shown that this is the landslide road. So that area and that specific elevation can be have a problem for that specific uh, people going through this road or people going through this way. Buffering is one of the application of GIS, because in different areas we have the different point of view that if I want to build a house, if I want to, for example, the government organization want to know that which area or which what type of habitat people or residential area or commercial area on the basis of road, or if we talk about the railway. So that is railway track. That is basically if we want to buffer the zone and we have the line data, so then we can get the nearest location of the area. For example, if I am interested to know about the 1 kilometer or 5 kilometer for the area, so then we can have the that specific area near to that road or near to that railway track for to know about the current situation and also to plan for some future. That is buffering on the road and points to find the nearest place. So that is basically they have applied the buffer zone on the road network and also on the point base where, for example, this is the settlement. So they want to know about the nearest area, or if I can say that there is okay some monitoring station. So they want to know the current status or current surrounding area of up to 5 kilometer or up to 1 kilometer, that what is near, and then it can be applicable that whenever we have that specific buffer zone, we can explain and we can have a highlight that what types of things or what type of data as within nearby in this roads or in this, for example, track. Regarding the modeling, we can see the modeling of, for example, the flood or any other, maybe the some other modeling that is the tsunami or something like that. So that modeling is very important for us. And also we can see the landslide modeling is also one of the key factor in current area. We can see here that is the area where we have either it is the deforestation or some landslide areas. So this is basically the modeling of the area. For example, if we can consider the model and also a 3D model of the ground area, so that it can show us that how it can be differentiated from the elevation based. Site selection for the combining a best condition for the multiple layers to come up with the best location for the proposed facility, that is the good slope drainage, enough distance from the stream and access to road. So that like we have in the attribute table, so that type of attribute should be shown within the backend of the data of the layer. So after that one, we can get the best site for the area. So now we can see here that the different hotspot and the different best location, or we can see the Fire Mountain Scout Camp outhouse locations analysis. This is one of the case study where the in the mountain scout camp can be held, and that is basically done using the GIS. So now what type of GIS and what type of layers should be used for the fire mountain scout camp house outhouse location analysis? So that type, like those type of things are very important for the specific location. That is one of the just case study, that if you want to know the best location, so it might be near to the road and also away from some other and near to the water bodies and something like that. So we can see here the different layers are there. We can see here the roads and also the 50-foot road access buffer and hydrology, 100-meter of hydrology and camp property. So that type of area within that specific location. So once we have this one area, so we can see here that those type of locations we can get by the by getting the analysis of the GIS and by GIS based layers and analysis. This is the habitat tracking and analysis for that specific area. We can see here that different layers are generated and different habitats or tracking and analysis has been done. So according to the tracking, now coming the question is that why habitat are tracked, or why, for example, how habitat can be tracked. Might be someone knows that a GPS was connected to one of the uh, ongoing habitat for eagle in the, I think, Saudi Arabia. So that was around activated uh, uh, for for few years, and it traveled more than few thousand kilometers for the whole. So that I just forgot to show the picture of that traveling and tracking area of that specific eagle, that how it can be explained, and it's better to see the development of the geographic information in the area and in the uh, how habitat can be mapped and tracked, and how it can be how we can help them to give them proper place, because they are traveling from one place to another. This is one of the inventory and how the GIS based map and GIS based analysis has been done for the different tracking and different mapping for the area. Healthcare, disease outbreak monitoring and modeling, affected at the risk poultry farm. Now, the thing is that, like, we can now see here that those type of poultry farm are at the risk. Okay, So now we need to make some buffer zone that, okay, this area, the surrounded area should not be, should be closed, and none of the people or none of the area should be included in that specific location, like this one and this one, because this area is affected. So here we can see that some of the buffer zones are generated on the basis of different disease or different flows. So we can see here this buffer, this one. So those type of buffer can help us that how it can be utilized and how it can be mitigate the effect of that flu to pass away from one place to another. This is also one of the example of the health-based GIS, that is SARS mapping. SARS distribution in the different area was like we can see here the distribution map, and also we can see the outbreak model uh, in the of different needs we can see from the point on the basis of using the GIS based analysis, which can help us to identify and to explain the things that how we can utilize the GIS based knowledge in uh, different parameters. Like currently, the COVID is the worldwide, I would say, disastrous situation where the GIS GIS has been used, and a lot of areas were tracked down and also back to one another. That because if you just let them move from one place to another, that would be just a disastrous situation within the area. So that type of analysis can be done using to consider the location of that patient or that specific area. So that is important to be identified. Query based analysis for the lung cancer uh, incidence within the area. Those are different queries has been done, and also the lung cancer within the area and different states, and by using by zip code. So different uh, different types of query you can use by just by clicking few points. So this is the New York State, so that they have the different zip code and then the analysis on the basis of that one. Facilities management for the municipal government. This is one of the example for the uh, for surveying and also facilitating the municipal government to how they can, for example, the pipeline or the some other main lines, how they can distribute to different areas. Route optimizations modeling, that is like currently even everyone is using that route optimization, where we have a less uh, route, less time consumption, and have as speed we can go. Crime analysis is one of the part. So here we can see the different crimes has been done, yeah, based on the point data. So they have just shown in the different location. Urban planning applications of GIS is one of the important and main cause of the urban planning. The geological mapping has been done for example, if we want to know urban planning. So some of the uh, for example, if we have the illusion, that is one of the sediment. So we need to know that either that sediment is, you can say, the hard rock or the soft rock or something like that. So that type of things are important within the specific location. Um, that is also one of the example for the area, and then we have the output result within the specific, that how urbanized or how area is defined within the specific location, or how we can put the urban area on this specific sites. Thank you so much. Thanks for your attention, and questions are welcome.
Thank you, Dr. Zishan. Let's see if we have any questions. Dr. Zishan, I just texted you one of the questions in the chat. Okay, one question is, if it helps in predicting what will happen in the future, then how does GIS view the issue of landslides?
Basically, like landslides are those are different natural disasters that cannot be stopped, but at least we can mitigate its effect from, for example, if we have a high risk area, so we need to move from one place, from that specific place, or we need to mitigate its effect. Like if I talk about the northern area of Pakistan. So that is basically in some area where we have a very high affected area, a high risk zone for the landslide. So then we have a high overflow on that road, where if we have some sliding, so that can directly move to river. So that type of planning is important for the landslide, because natural disasters, you cannot stop it, but at least you can mitigate its effect. For example, if earthquake happen, floods, those type of natural hazards. So that is important to be uh, considered and mitigate its effect for the area.
Okay, if there are any questions, you may raise your hand and I'll unmute you. We'll just take a couple of questions. Go ahead, Mohammed Sahib.
Hello, Assalamu alaikum. Dr. Mohammed Shanali, are you listening me?
Yes, I can listen.
Sir, I want to ask that, as in the case of deserts, the amount of water, or is there groundwater available in deserts? By the application of GIS, we can predict about the water availability in deserts, or in Cholistan, as in the areas of Thar. Is it possible?
There are some GIS based, remote sensing based images which can help us to find the groundwater anomalies, and also can be further processed using the GIS. So yes, that can be done for the Cholistan or some areas. But although there would be not, there will be some limitations within that analysis, but still you can, we can do that analysis, and we can be do. Some of the scientists have already done that analysis in the Cholistan and also some other areas as well, for the groundwater change and also for the temporal change.
Okay, Walila, you may ask your question.
Baru.
I think those are all the questions. To all the participants that are asking for presentation slides, after the training ends, we will compile all the presentations from our speakers, and then we will upload them on a Google Drive and share them all with you. So do not worry about the presentation slides. We'll compile them at the end and share them with you. I think Dr. Zishan, that's all of the questions. Over to you.
Okay, thank you so much.
So thank you so much, Dr. Zishan. So we will take a break now for 10 minutes before we
Yes.
start our technical session, hands-on exercise. So it's 10 past 2 right now. So we'll be back in 10 minutes. That's 20 past 2. So everybody just take a breather and we will resume in 10 minutes. Thank you.
Yeah, sure. Thank you so much. Thanks for the audience. Thank you, everyone. Bye.
Yeah, assalamu alaikum.
Walaikum assalam.
I think he has a question. Let me see if I can unmute it.
Yeah, assalamu alaikum.
Walaikum
I'm Oliver from the University in Uganda. If we look at the starting of GIS started in 1906, and it's simply mentioned in Uganda, I'm not seeing it yet. And in Uganda, we have frequent landslides, and I wonder how is the predictions being worked in Uganda because that was just abrupt.
I cannot get you because there are a lot of echoes.
They cannot get
Can you kindly just write your question in the chat box because there's a lot of distortion. So just write it in the chat box and I'll ask Dr. Zishan to answer it. Thank you. over to you, Ms. Benazir. You can share your screen and we'll start in just a minute. Ms. Benazir, can you hear me?
Yes, you are audible.
Yeah, you can share your screen now and start. Thank you.
Okay. Uh, Please, if you can allow my second ID,
Sure, I'll do it.
because
It's done. Ma'am, if you're ready, you can start.
yeah, okay. Hello, everyone. Assalamu alaikum. Yesterday we have talked about the RGS desktop and its softwares, which will appear after installing the RGS software in your computers. So, and we have we talk a lot about the interface of ArcMap, and we have talked about the georeferencing, absolute georeferencing, and relative georeferencing. And also we have talked about the geodatabases. So one other thing, which I have to, I forgot to show you guys that using a search in ArcMap, that if we have, yes, we have a toolbox, where we will use, which we have to use in our analysis. There are a lot of hundreds and thousands of tools, and also people are engaged in developing the new tools for new analysis, new spatial analysis in our map. So if we are wondering that where any tool, any specific tool which we need in our for our analysis, where it is in some specific category, like we have, let's say we have 3D analysis tool, and we have analysis tool, and let's say data management tool. And this data management tool, we have a lot of other tools, toolboxes in this tool box. So rather to be confused and they're searching these the specific tools and this gallery of toolboxes, we have another option for using a search in ArcMap, right? So you have, what you have to do, actually I have pinned it here, but if we go to the Windows, and we have here we have a search button in the Windows drop down box. So using the search in ArcMap is ArcGIS includes the ability to search for GIS contents to put it working quickly. For example, if we by adding a search result to your map, or by inserting a result item into a geoprocessing operation, if you are processing some kind of operation in ArcMap, so we can easily go or reach to these specific tools through a search box. So let's say if you need any raster analysis or anything like that, like if I say extraction by mass, so it will right over here, whatever you want to search for your geoprocessing operations, you have you just to write over here and just press the search button, and you will find the tools within this box. Okay, so that was all about the search, using search and ArcMap. So last time, like in yesterday class, we talked about the geodatabases, right? And we made a geodatabase in our here, and we create a feature data set as well. Okay. Let's say I have a practice online. This is our catalog. If you guys remember yesterday class, I have told you that it just work as a window explorer, like we have in a Windows, or we can, or if you are using a Mac, so you can relate it with a Finder, right? It provides a tree view of your data, your files which are used in ArcMap, right? We made 2 data sets, and in one we named a new map, and in this data set, feature data set, we have we create 3 feature classes. That's one is polygon, point, and line. So today I'll be show you that we have another option for creating the feature class. We can name it a shapefile. Actually, shapefile and feature class are something like similar things. That is, shapefile was the old name of feature class, which are used in ArcView or ArcMap when it was discovered. So it is like in a shapefile, in both in feature class and shapefile, yes, both in feature class and shapefile. Am I audible, Mr. Harris?
Yes, we can hear you.
Okay, thank you. So shapefile or feature class, both are the same things, and we have talked about the feature class that is a homogeneous collection of common features that will share a common projection system, common attribute tables, and common and they have a common geometry. If a single feature class will have a common geometry, but in feature data set, they don't need to, we don't need to have they don't need to have a single geometry in that feature data set. But yes, only feature class can have a single geometry and will share a common attribute system. So what was the main thing? The main thing I was showing you guys was that right click, how to create a shapefile. But there is a little difference between creating the shapefile and the feature class. Like if we right click on this geodatabase and we click on a new, let me not into geodatabase, but if we right click on this folder, why we don't have an option of creating a new shapefile in the geodatabase? Because we in geodatabase format we have a feature class instead of shapefile. This is just a name conventions. That shapefile and feature class, these are all just a name conventions. Okay. So if we right click on the folder, so go to the new and we have an option shapefile. So click on that, create new shapefile. Name it like we can name it maybe what is for cities, right? And we have feature tab, geometry tab is polygon. And if you remember, and while creating a feature class, we have a single option, or we have a separate options of this name and this geometry tab, and also we go next to that special reference in order to define the projection system of that special feature class. But in the shapefile, we have a single, like we have everything in a single dialog box. And let's go to edit to define this projection system, go to geographic coordinate system, and then go to world and WGS 1984, click OK. So in this shapefile, we have a name of this shapefile, right? We have a geometry tab, we define the coordinate system, but in that shapefile, we cannot create any attribute table or any attribute field names. We haven't any option of giving the field name or anything, any attribute signs in this shapefile. After creating that shapefile, we can edit the attribute table of this shapefile, but in the same way, in a one click or in one process, in a continuous process, we cannot create an attribute table of this shapefile. So this is a little difference between a feature class and creating shapefile. That's why if you, and this shapefile also remain scattered in your folders and something like that. So yeah, it's a feature class is now is preferable because it feature class are embedded in a container that is geodatabase. So if we click OK on that, so here you can see, if you can see a cities a map layer is added to our table of content in our map document, that is cities. So if you see the cities, so we can right click on this cities, open attribute table. So we don't have any option of this attribute table. That's we cannot see anything, or no option was available for editing the attribute table of this shapefile. So what we will do, right, click on the first option, or first small white box right below the table. Let's click on that, and you have to add a field. So now here you can see the option we had yesterday in our class, and while creating feature class. So name this field, like I have I want to know the name of the city, so just click on a name. Now this type, what should be the type of this data which we will be put in that very shapefile is that we have to, this is name, so we can click on text. So field properties length, yes, we will not exceed or name of this and more than 50 characters. So let's go to OK. So we can see that one field is added to name to it, right? So this city's shapefile have attribute table, but this shapefile cannot have attribute table while creating in one process, in continuous process. But if I show you the last the feature data set, we had created a last, click on that, right? Just drag this, I have just clicked on the new map and just drag this feature data set and put it on my table of content. So I have we have done with school shapefile, that is point shapefile, line and a polygon, that's statistics. So if I right click on that, if you go to the layer properties, or right click on this map layer of school, which we had met yesterday. So if I right click on that and open attribute tables, so we can see the name of the school, the population is connected to that area, to that specific feature class. So we can see that attribute table is made or is processed in a one continuous process. So that is the little differences between the shapefile and feature class, although its function is same, right? So now we will go toward how to make a map. So these are all about how to start the map making, how to start the digitization, how to start the editing. So what is actually digitization? Digitization is the process of converting features or information into digital format, like a computer readable format. And it is one way to create a data, to create your own data. Although we have a lot of sources for from where we can get our data, this remote sensing based data sets we have. So how to create our data, how to create computer readable format data to our own way to create data is a process. We can make it through a process known as digitization. And there are two ways to start digitization. One way is to right click on the specific layer in the table of content. Okay, right click on this specific layer on the table of content and go to the edit feature and start editing. That is the one way to start edit session in your digitization process. Another way is to start editing or to start digitization is that let me off this tool. If you don't see that the editor tool bar over here, so what you can do, you can right click on the standard amendment toolbar and go to the editor. So if you click it, your editor toolbar will appear here. Just fix it over here, right? Now, all the tools in the editor toolbar are not functionable, are not working properly, are just lighting because of we don't have start any edit session. So we can click on that start editing and start editing. So if we click on this, right, start editing. So this dialog box will be open. So it asks me to which specific layer I have to start the digitization. So maybe it's cities. I'm only interested in cities, or only in districts, or rivers, or school. But one thing should be clear, that if I click on the one of the layer that I have created or we have created in our previous class, that is schools, rivers, and districts That belong to one feature class. If you remember, let me separate the cities, wait, so that to avoid confusion. Okay, right. So if we see that we had created feature class, 3 feature classes, point, line, and polygon. If I click on any one of them, so both of 3 feature classes will be editable, right? But if I created a number of shapefiles, that is shapefile for a polygon, for shapefile for a point geometry, for line geometry, so it will ask separately to start edit session for a specific feature class. But in feature data set, it will never ask me to start edit session for any one of them. But although I can switch the edit session between these 3 classes, or a number of classes which we have created in the feature data sets, right? So editor, start editing. I say I have to start editing in school, click OK. Okay, so now we can see that that our edit toolbar is now functionable, or we can see that every toolbar is now functionable in the editor toolbar, right? So go to the let me remove this one so that to avoid confusion. Right. So this is the editor toolbar. Start from editor right up to create that pencil and that page like icon. Is if you place a cursor on that icon, so you can see the create features option. So click on that create features, right? I have 3 feature classes in that create feature box. So what I've said that, okay, I have started only a session for schools, but is that feature data set also includes the districts and drivers and other feature data sets? So it start edit session for all of the 3 layers. But it's up to your choice. If either you can switch between these feature classes you want to edit your session, or if you can also go with single one and just finish your task and save edits, right? Let's go for a polygon first. Here we can see if I click on the district feature class, right below the create feature box, we can see a construction tools, right? In construction tools, we can see that we have a polygon, we have rectangle, we have circle, we have ellipse, and we have autocomplete polygons and many more, right? In that construction tools, you are free to select any one of them, and you can start your edit session. So let's click on polygon, right? Let me zoom into this in a small district. Let me select some small district to be digitized. So sorry. So let's start digitization from here. Okay, the more you zoom in your contents or your data, from where you want to digitize, or from where you want to mark the boundary lines of any specific area of interest, the more you zoom into the area of the boundary of the area, the more accurate will be the your data, your new vector shapefile or new vector data. So let's say if I zoom out to this this very image of which we have georeferenced yesterday. So maybe I missed some curves, some turns in this, some curves in this shapefile, or some in this very the boundary of these districts. So if I zoom into it, so the more accurate I can have see the curves of this district. While during edit session, if you see this, if you see that this purplish color thing where gonna disturb, you are going to hide the things which are below your digitization session. So you can do also you can do hollow this this polygon. So what you have to do, you have to do just to go to this that specific feature class. You can see a small icon below the districts or below that very specific feature class. Click on that simply. You have many more options for coloring your polygon, but if I want it to hollow and I want it to give it some outline width like up to 2 and have a color of red, so we can do it, right? So when I start another session, it will go same as I did. Okay, right? So if I click here, we have two options or in the standard toolbar, that is, one is select feature and other is clear selected feature. So we can see that the polygon we have created is selected. So whenever it is like something like a sky blue color or sometimes something like this, so you must have an idea about the selection of this layer. So I have just click on it, clear selected feature. So if I want to see the polygon which I have drawn, so just click on this checkbox, just check out this copy image from here, and now I have this district boundary of the area of interest, right? If I click again on the copy image, so it will appear below the polygon, right? If now this is all about the polygon feature. If I want to create some linear feature or to mark some linear feature in the map, so I can easily switch between these three feature classes. So what I have to do, just go to the reverse linear feature, click on this linear feature. So as we click on the linear feature, we can see that the construction tools below are changing according to the feature class. So first one, for polygon, we have option for polygon. We have the option of polygon construction tools, and for linear feature, we have a linear feature construction tools options. One thing I have to let me quickly go to the polygon. One thing is other, that's autocomplete polygon. Well, it's best thing in the polygon construction tool is autocomplete polygon. If you have a lot of data to be digitized, like this have like this points have more than 26 districts almost. So if you don't want to repeat the same boundary of the two districts, if two polygons, let's forget about the districts or something like that, if you have two polygons, right, and these two polygons sharing the same boundary, so you don't need to repeat this, create the or to repeat or follow the same boundary of the sharing boundary of the two polygons. What you have to do, you just have to select the autocomplete polygon, right, and it will autocomplete the polygon without repeating the boundary of that the shared boundary of these two polygons. Let me show you. Let's say if I have create this one, if it's here, the boundary from here to here. Okay, so what I need, I only have to double click on that. So it create another polygon. Let me off this image. It will create another polygon without repeating the construction of this shared boundary. The main with the important thing or important or significant function of this autocomplete polygon is that if we construct or we construct the same boundary of the two polygon which they are sharing, so there must be overlapping over here, maybe in order to avoid these overlapping or gaps between these two shared boundaries. So we can have a autocomplete polygon option, so we can create the a polygon without overlapping or spacing things like that, right? So we have to go to another thing, right? So we were about to draw a linear feature. So click on this linear feature, or click on line, just create, this is our river here. I have to create a, so this is a line feature which I have drawn in the polygon. Okay, right? It's a linear feature, and let me show you some of the point feature to be created. So let me show you create feature, schools, point. So with every feature class, you have you have to see the respective construction tool of that feature class. So for this, we have to click on point. Let me take one point of this district, and let me take one point of this district, right? So I just uncheck this copy image and click on this clear selected feature. So we can see that this point is selected. Now, if I clear the selection, so it will clear the selection. Right. So this is this was all about the point line polygon, or we can say digitization and the arc map, and it's the way or your own way to create your own data. So after digitization, let's say if I have this shape file, let me ask an audience if they have some questions, so that I can move forward. If someone have questions, you can ask, please. If there is no question, then I think I have to move forward because we have short of time and we have a lot of things to do. So here I want to show you another thing, that if you have a lot of data, and let's say if you need only this polygon or this boundary of this district, so you don't need to have redigitize this boundary of the districts, and you don't need to have waste your time on that. So what you can do, you can separate these two polygons by creating a new features. How to create a new feature? Actually, these two polygons and points and line are just a one shape file, three feature classes in one feature data set. But if you are interested in this polygon only, and you don't need any river in that, and any point data in that, and no connection with other districts or other polygons, so what you can do, okay, so if I select and okay, so what we have to do if we need only this polygon over here, so we will go to select feature. Select feature will select the feature. Okay, if you have edit a lot of things, it doesn't, you have just create your document and this ArcMap document. No edit will be saved if you don't save your edits. So just click after editing, if you are, when you are finished with your editing. So what you have to do, you have to go to the editor toolbar and you have to stop editing. But before stop editing, you have to save your edits, right? After saving all the edits made since that last save, after saving, you cannot undo previous editing operation. So it's okay, it's fine if you are, if you, after saving edits, if you want to remove your something you have to add or remove from your vector file, you can do that. It's not that fixed rule. So we have to do save edits, right? Stop editing. Now, if I want to have this polygon only, so I will go to the selection. I will select this polygon only and go to that district shape file. I will right click on it, go to selection, create layer from a selected feature. So we have a lot of features. Let's say we have a lot of features in our ArcMap documents, right? And we have we need only a one polygon, so we have to create one single layer from the selected feature. We want to create it, so what you have to do, click on it, and it will make also, although it will be a part of the same same feature class, but what it will be do, it will create another feature class or another polygon shape file for this for only this way polygon. Let me show you that. If I just turn off all the layers and I just select this thing, that is a district selection. So what I have done, I have select the features from this district shape file or this district feature class, right? You can go to the properties of this polygon. You can change the color, give it a blue color, olive. You can have outline. You can change the outline. You can also change the outline color. Make it some blue, something like that. Okay, so that is that we got the polygon. That is, if we click on the district, it is also the part of this district feature class, but also it now a separate layer. But if you want to create, if you want to save it as a separate layer, because it's just a temporary selection of this layer. So if you want it to a permanent selection of this layer, so you have, what you have to do, you have to right click on this, that selected feature which you have separate from the main feature class. So just right click on that district selection, data, and export data. So what will do export data do, save the layer that which we have selected or we from the other feature class, and it will save it as a shape file. So let me show you that. Export data, export all feature which we have selected in from the district selection. Yes, we can give a name, we can give a folder to it. Let me give it a folder of that is practice online, right? And now, so the extension of a shape file or any feature class will be an SHP, .shp. So now I can rename it. New underscore district. Save it here. Okay. So now another dialog box will be open, which will ask you, do you want to add the exported data to the map as a layer? No, we don't want it because we already have this layer. or if you wanted to have your the data, the exported data, to add that exported data to as a map layer, so you can also add it. So if I go to, if I select, let's say if I select the yes, then I have another option. I got the new district shapefile of that very polygon, right? This district selection, don't be confused in this new district selection and district selection. District selection is the only selection which we have done in only in ArcMap document, and it will be only in that very case, in that very ArcMap document only. It will never be appear in somewhere in our files which we have saved in our computer. But when we export this selection, so it means that that this layer act is a separate layer now. So we can add anything to this layer. We can also if this polygon contain many other information, so we can remove this information from here, and we can also add information separately here. So now this so this is the one way to have a data in a very easy way without wasting our time and redigitizing or reconstructing the polygon or any thing like that. Right. So another thing, important thing was that if I want to clip the data, that I'm going accordingly to the tutorial which I have given to you guys. That's another thing is clipping. Clipping is like, let me remove all these layers. Don't need it. Right. So clear selection. So what if we need some data and we want to clip some data in some polygon? So what we will do, we'll go to the ARC toolbox, analysis tools. We have option of extract, overlay, proximity, and statistics. So in first option, you go to the clip, extract, and go to the clip. So now here, wait. For clipping, we need some kind of boundaries or some kind of functions that we want to clip from here. So let me, if you remember, we have created a cities shapefile over here. So let me start editing for this shapefile. Created cities polygon. If we need only this part of the vector data, so what we will do, we'll save our edits, stop editing, and what we will do, we'll go to our toolbox, clip, input features. From input features, I need this dialog box will be open. It will ask you for input features. From input features, we can select the districts. Clip feature, the feature which we want to clip it. So we have a polygon, or we have features which are clipped by this polygon. So you will select the cities shapefile, right? Let's say it will ask you for pathway or for folder we want to save. So, but let's make it by default. So okay, processing will start, and we have, whenever you see this, whenever geoprocessing operation are operating in this ArcMap environment, if you see this type of message, so that the message pop up from that very portion of the ArcMap environment. So it has the information of either our geoprocessing operation was done or not. Okay, if it is done, so we will have a green tick over here. If it's not done, so we will have a message over here, and we will also have a red cross over here that our geoprocessing operations were not successfully done, right? So now if I remove all other layers, so what I have these things, district clip, right? So these boundaries are clipped by clipping tool. So if you need it for your studies or if you want to have some specific data from your from your data from your other vector files, you can clip it like this. So let me off this districts and let me off this as well. Okay, so now we'll go to our another operation is that I think Dr. Zishan had talked a lot about the buffering and its importance, why we buffer any roads at any points, anything we need a buffering for some proximity operations, like so buffering is something to have direct area in all direction from that very object, right? So for buffering, and he had a very great explanation about buffering as well. So for buffering, if we want to buffer this line, so we will go to the proximity tool, the analysis tool, and analysis tool will go for proximity and buffer. Input feature will be a rivers. Let's see, we have to buffer the river, a linear feature in our feature class. Okay, right? So it will ask you for output feature class. So we will click it as okay, make it by default linear unit. We need to give a linear unit here. So let's say I want to have a 10,000 meters distance from here. Okay. Okay. So now another pop-up message is here. So buffering is done by that is on either side of this river. I got a 10,000 meters distance from this river, like 10,000 meter distance on the either side of this river. It's from here, this is the main river. So on the right side, we have the 10,000 meter distance. And on the left side, we also have a 10,000 meter distance from that very main river. It might be a road or any linear feature. Okay, buffering will be, I have already provide a detailed document of buffering. That is, buffering can be done on both on every vector data set, to every vector data set, that may be point data, or maybe line data, or maybe polygon data. You can create buffer around the point, along the river, along the linear features, are also along the polygons as well. But the result will be saved in a polygon. Okay, either you are creating a buffer for a linear feature, or for a point feature, or for polygon. Buffer will save its data in polygon. Okay, so that was all about, and we have a multi-ring buffer. So I think we should proceed forward. I have already give you a tutorial for multi-ring buffering. Multi-ring buffering is just when periodically we want to have some distance from the main features. Like if we have, okay, we have a message that I'm sorry, yesterday I was not able to. In the class, could you please tell me what I can combine to shape files and individual color tables and single shape files? Yes, you can combine shape files, bring it to your ArcMap document, right? Go to the editor toolbar, and here you can merge two or more selected features for the same layer into one feature. And if you want to merge it into two shape files, so yes, you can do it by bringing it into the ArcMap environment, and you can merge both of the shape files in your ArcMap document. Okay, so what we will do, so multi-ring buffer is just like a periodic distance from a single feature, that maybe from points. That is, let's say if we have if we have a plant for an atomic plant, so from that plant, if we need to have a buffer zone of 10 kilometer, of 20 kilometer, and 30 kilometer. So more, the safer zone will be a 30 kilometer, and second will be the 20 kilometer, and the more dangerous zone must be will be a 10 kilometer within from that power plant, right? So these are, if you want a periodic distance from from any feature, so you can you can use a multi-ring buffer tools in ArcMap. So we will go to how for map layout. So yesterday I have talked about that map we have essentials of maps, that when you create a map in ArcMap document or ArcMap environment, you have to care about almost 6 elements. That is most important elements of the for creating a new map, right? We have two views here, that is data view and layout view, right? In data view, we can create our data sets, we can create our data, we can create our maps over here, we can digitize, we can edit our sessions. While in layout view, we can create our map, our final map over here. For map, we also have, for every operation, for every geoprocessing operation in ArcMap, we have a toolbars. So for map layout, we have a toolbar. You can right click on that menu toolbar and go to the layout tool. So I already selected it, right? So we have this toolbar, which we will use for the whole map data frame, right? Another thing, the important thing before discussing the map elements and what are the essential of maps for map creation. So I will show you that we have discussed in yesterday class that also, that is, although there is a web GIS or enterprise GIS, but we have option to connect or to reach that web GIS or online GIS from our ArcMap as well. So how we can have, let's say, here in add data button, we have in a small arrow. So right, click on that arrow. You have the option in drop down box. You have three options, that is add data, add base maps, and add data from ArcGIS Online. So here you can add data from ArcGIS Online as well. So if I want to add a base map to my document, so I have click on, we have a gallery of maps over here. So click on that add base map. So we have a gallery of maps over here, like we have satellite imagery, we have satellite imagery with labels, we have street map, we have topographic map, we have dark gray canvas and light gray canvas in oceans, terrain with labels, and national geographic and OpenStreetMap. We have a lot of maps, or we have a lot of options over here. So it will go the exact where our data is lying in the real world location. So let's say I have select this terrain with labels. Let me click it. But for this online base maps which we have, which you are gonna select for your mapping purposes, you must need good internet connection, right? So if you do not have good internet connection, you might face some problems while creating the map from base map, right? So always check in this in your computer that your RGS is connected to the RGS online. Yes, currently I'm not signed in, but yes, my RGS connected to online resources. If it is not, so it will a small red cross will be on that globe icon, right? So just click on that, it will just connect the RGS to online resources. So as we have some internet issues, I think, so we are not able to add the data over here. Sweet part. Okay, I mean we don't have any good internet connection, so just okay. God, okay. So here I selected the two districts from not only one district, the other one was half. So it will just go to exact where my vector data lies. So let's remove this layer because I think we are having some problems while loading this map. So let's wait if it shows here, so we can remove it from here. Wait, no, we don't need any hardware selection. So here in table of content, you see that you have two options. One layer, another layer is added to your table of content. This is base map, and in this base map, we have selected a world terrain base map, right? So it goes where my polygon actually lies in the real world location. So this is how it works, right? So online, this is how we connected to the online maps around the world. I have created such type of map. Let me show you this map. It's a map of my own paper over here. So I will show you how these insert maps are work here, or how we can add other data frames to the existing data frames. But just I want to show you that I have make a map like for Peshawar Basin. So that's how it works, or how it looks like, right? And here it's by default, this text is by default from the base map. So let's go back to the alt map document. We have removed. Don't need it over here. Okay, let's wait for removing it. Okay, so we have discussed that map have 5 or 6 basic elements any map must contain. So that is title. We must have a good title for a map in order to attract the audience. The title of the map gives audience contextual information. So we must have a good title of any map. So title is most important for any map. So by providing contextual information which the audience need to use the map properly for their purposes. Another thing is legends, right? Legends are the things. Let me add a title first. Let's say we have options. All of the basic elements for a map we can add it from here. Insert option. So here we have option of data frame and title as well. So let's talk about the data frame. Sorry, I have to go back again. We have a map like I have shown you that we have this. I have this main map of Peshawar Basin. It's not showing. Okay, I have this Peshawar Basin map, right? So these two data frame are how we add this data frame, or what we call this data frame in a single map. We call it inset map. So this inset map gives just a glance of from where we took the data, or where our districts, or where our area of interest lies in the world, and a specific location. Like in Pakistan, it's located in Khyber Pakhtunkhwa province, and in this province, it's located over here. So we have two inset map: one of the country map, then a province map, and then a basin map, right? So you can create this map like insert a new data frame. So when you add a data frame over here, you can fix it somewhere there, right? You want it. Okay. You can add the data. Let's say I'm adding that map over here, right? That I just took these two polygons from here, so I can use these this inset map. But we must have the coordinates up here. Okay, let's talk about in grid section. We will talk about the grid in this inset map as well. Okay, so first is the title, right? If I go to insert, add a title. Let's say I have the title of district map, right? Okay, we have option to drag it here. This is the first essential element, and your title must be enough attractive to attract the audience that they are viewing your map. Another thing is legends. What your map is showing actually. Legends, a map legend or map key is also called a map key. It is an explanation of the symbols, or we can say a pictorial language and convention of a map. That what are these things? What this dot shows, what this linear feature shows, what this red line shows. So all of these things will be appear in a legends. So legends will be. It's just how it's legend or content. It's design, and it's design and placement just are important, because a map can fail to communicate with the audience when we don't have good legends or here. It actually gave a message what we have in our map. So go to insert again. Let's go to the legend, right? In this legend, we have option that what we want to add to the map, right? So schools, rivers, river buffer clips, or we have a lot of options. So some of the options are already selected over here. That is schools and rivers and district, right? So if we want to remove some of the layer, so we can select here in legend items, right? And click on this back arrow. It will remove the items from the legend items. If you want to add it again, so what we will do, click on the schools. Okay, let's sorry, districts, and again edit. This double arrow will edit, and this single arrow back arrow will remove from here. Okay. I'm sorry. Let me, let's edit school and reverse and distance. Right, it will show also, this dialog box will also ask you set the number of columns in your legends. Let's say if you have a map which have a lot of legends, like if you create a soil map of any area, once I've created a soil map of Pakistan, so we have more than 60 legends of this map. So these legends were not, we cannot put it in a single column. So it will not look good, and it will never represent the map very in accurate way, right? If it asks, if you have a lot of data and a lot of legends in the map, so what you have to do, you have just to select the option over here that is set the number of columns in your legends. So if I have only three legend items, so I can go for one column. If you have more than three, if you have more than 3 or 5 or 6 or 10 or up to 100 of legends, so you can divide these legends columns into 1, 2, 3 up to so on, whatever you want it, right? We'll go to the next. So these legends will be appear in a single column. So this is the legend title. We don't need to give a legend title. So if we add, let's say if we add a legend title, so it will appear in the top of the legends. We have we don't need any legend titles, so we will just remove it. Legend title font properties. So whatever you want to give a legend title, so you can format the properties of the text of the title right over here, like it colored. You can play with the size and bold and italic or underline, whatever you want to do with it. In the next dialog box, we have a border of these legends frame, and now it's all about the legend frame. So how you want it to have on your map. So it's border, it's background, it's drop shadows, and something like that. But we will go. Yes, you can edit your legends after that as well, not in one continuous way. So let's go for next. Go ahead, make it legend items. It will give your height here, it will bet here. So make it by default, finish it. So now we have legend over here, right? If you want to, let's say, go to the properties. So the same properties, layout, its frame, its size and position, although we can play with it also after creating the legends. Let's say I want to have some lighter background or some darker light gray background for it. So apply it and okay. So you can check. We have a frame, legend frame. Some top color, right? Fix it or somewhere you wanted to place it. Okay, so let's take a pen. Some zoom in to have your map like that. These are the two essential. That is title and legend of the map. Another one is scale of the map. Scale of the map is I don't remember if someone talked about the scale. That is, scale is a unit of is a map essential which explain the size relationship between one or two dimensional feature in the map. So the scale is actually the unit of map to the ground. So what is showing on the map and what is ratio to the ground, right? And we have three tabs that is here over here. That's we can have a scale bar, we can have a representative fraction, And we can, this is a long story, but we can have different type of scale over here. But third essential is scale. So we will go to the insert and we'll go to the scale bar. Let's say I don't want to have it in a mile, so let's have it in kilometers. I want to select this one. Okay, right. Fix it somewhere you want it. Right click on this scale bar. You can change the properties of the scale bar. If you want to have some frame properties, you want to change the background, same, and want to keep it same like legends, so you can do that. And also for scale units, go to the scale units to change the appearance or the unit of the divisions. Let's say if you have in kilometers, you may change it to meters, mile, or millimeters, or something in any environment you want, in any unit you want it, right? Label position after levels. And let's say if we have position of these 5, 10, and kilometers, so we'll leave it by default after labels. And label, how it label will be shown in kilometer or km. So let's do km. Select km for that. Km, apply, and okay. So first we have kilometers over here. Now we have just km representation of kilometer. The third essential of a map. Fourth essential is direction. Yes, north arrow. North arrows actually allow viewer to determine the direction of the map. If you know exactly about the about your north, you can easily find where is your east, south, and west lies, right? So for this, we will go to the insert north arrow. So we have a lot of options for designs for the north arrow. You can select in any one of them. Let's select this one. Click OK. Place it over here. Is another essential of a map, right? Also, it has the same things that you can right click on that and go to the properties, and you can change the properties of this very north arrow, right? Another thing is labels. Yes, if you want to label it, so I also don't label it for my feature class. Let's label it. Show you. If you don't have label it, go for a data view. I just forgot to label to play with some attribute table. We have a short of time, so is we have options. We will add a field name. Okay, sorry, we already have this. So for this, we will start editing. Sticks. Okay, and we will right click on that, go to the attribute table, and just click on name. Name will be, we have some name of this district 100. Right. Click OK. Close it. So we can see, we can have label over here. If you don't want to label the map, this is the same process for every shape file. You can name your linear shape file, your point shape file, and polygon as well. So if you don't want label here, just click on this, uncheck the label feature, and then you can have a click feature over here. Okay, go for labels. If you don't label, if you forget to label, or you don't have if you want to label your data in some other way, so you can also add a text to here. So you can have insert and add a text, and you can go with it. Another important thing is The last, but not the least important thing is the grids. Set over here. Okay. So not all map use actually the grids, but grids are important. So if we go to the properties of the map, okay, go to the grid, new grid, make it, leave it by default on the levels only. You can change the decrement second option here. Go for next. We don't need any minor division text. So we'll just uncheck this minor division text. Next. Finish. We will finish it. Apply. Okay. So if we want to have some levels with some board which has a greater size, like here we can give it 8 and board. Try and okay. So now here is the map. We add the grids over here to this map. Also, if you ever put ever add the inset map to your map, so this map must need to have grids on that and its data frame, right? So it's all about the map layout. Let's export this map layout. Export map. Yes, if you want to have don't want to have this by default map data frame or map layout layout style, so you can go to page and print setup. You can change the paper size, its source, and its width, its height over here. So just you have to uncheck this box and just change the width and height of the map according to the data, according to the map you want to make it, right? So let's export this map. This map is only readable here, but we to export it, to use it for, we need to export it like so district map. And now you can change. You can let's say I have just select the files where I want to put this map, practice online. It will save the type as JPG. You have all other options, so you can select it. You can change the resolution, width, and height according to your need. You can change the DPI, or you can increase or decrease it. So select it, save it. Right. Let's go to the we have a map over here. Here it is. Now we have create a map. This is just a map for practice, so you can add the grids to your inset map as well. But the essential of maps are title of the map, the north arrow, the legends, what actually give a message to the audience. So it will show by the it actually communicates with the audience which are using the map, or who are reading these maps. So this, let's say this dot show the school, this linear feature river, blue line show the rivers, and this boundary is the district. So now if anyone can read this map, oh yes, these are the schools over here, and these are the river over here, and these are polygon or there's a district somewhere in this province. So this insert map will give the option over here, option of information of this this data. So it's all about map layout. Yes, another thing, most important thing which I have forgot to show you is that how I just is like I made a map, how to draw these lines, these from these insert maps. So what we will do in this drawing options, if you don't have any drawing option in your art map, so just right click on that and just select this toolbar over here. So we have to click on that. Just take a linear feature from here. Let's say we have a district over here. Second. You can change, and also by right click on this line, you can change the properties of this line, length and size and position and symbol as well. You can change the red color of this line. Right, we can select another line part. Let's say we have, let's say it's not it didn't look very good, but actually I want to show you how it works. Okay, so here it is, and you can change the properties of this these lines as well. So that's all about map layout in the arc map. So if anyone have questions. Okay, what is normally considered is an ideal scale for A4 size? Yeah, it's totally depend upon your map. Let's say if in one study I have made a map in which I have two insert map as well, and one was by area of interest. So in insert map we usually put the country map or we can say the province map or some the area which is represented here in the main map document. So in that map, let's say we in this case we need to select that the miles, let's say miles for insert map and kilometers for our smaller areas, because if we have a country map, right? So the country map may be in a miles, so it's they have maps have a large scale. And if we have a province map, so it may be and also in the miles, but if we have a district map, so we can select the kilometers for it. So it's totally depend upon your data. Yes, Muhammad Ijazuddin. Yes, you can unmute your mic and ask your question. Sorry, I cannot pronounce this one, but who are raising their hand, you can unmute your mic.
Alcatel, we're trying to unmute you, but we're not able to. If you have a question, please unmute your mic and ask the question, or else we can move on. I guess we can move on with the Mr. Jaz, do you want to ask a question?
Yes, sir. I would like to ask one question.
Okay, yes, you can ask a question.
Ma'am, when we are going to add the points like hospital or school, so can we add through directly XY point by adding the coordinates of these points by collecting through GPS or through Google Maps?
Yes, yes.
Or it is necessary to go to the editing panel and then we add over there?
No. Yes, you may have your point data if you mark some points in Google Earth, let's say, and you have point data over there. And if you want to bring these points to the Earth map, these points will be must be in a KMZ file. Yes, in KMZ format. So what you have to do, you have to convert these KMZ file format into shapefile, and the conversion tool. Then if you click on this Earth toolbox, go to conversion tool. From KML or KMZ, you can bring it to shapefile or a layer format. So when you bring it to a layer, so you also want, if you want to display it here, so you can display it. But if you want it in a vector data format, so you can have a exact point over there where your points are lying. For GPS, if you have a GPS points, there is a another method which you have to convert these your points from degree, minute, second to decimals. That you have to do all this formatting in Excel. Sorry.
Okay. Thank you, ma'am. I got the point. Thank you.
Yes.
Okay, ma'am. I got it.
Okay. You're welcome. Muhammad Ijazuddin, you can ask your question. Unmuting your mic, please. If you have some query, please unmute your mic. Okay, what if you need to show more than 2 inset maps, for example, country points, the state or city? Yes, it's okay. Let me share the screen again. So you can do it simply by adding more data frames. Like if this is one main data frame, right? And this is another data frame insert map. Let me take these things away from it. So to avoid confusion. Okay, we have one insert map. Let's see for a country. And simply add. So what you need, you have to select the proper or the correct data frame in which you are adding in other data frames. So insert, go to insert, add another data frame. That must be for your districts or points. And you have another data frame for your stat as well. And you can add a multiple data frame to add a multiple insert maps. So it's not a terms of rule that you can add only 1 or 2 insert map. You can add more than 2 or 3 or 4 or 5 data frames in a single data frame to show your data. Okay. Okay, attribute is something which is behind this vector data. It's a spatial data. One is spatial data, and other one is spatial data. What we have, I don't know if you learned anything about spatial and spatial data in previous lectures, but for vector data, we say that it's a spatial data, and the tabular data which is connected with that spatial data is known as attribute data. Let's say we have attribute table for any of this feature class, right? But the legends are the pictorial representation. Let's say if this is a point, it shows a point over here. If this is a line, linear feature, it shows a line with the same color. And if it's a polygon feature, so it shows an enclosed polygon and name it a district. So it's just a communication with the audience. It's just a pictorial representation of what you are showing in your map, what you are giving message to your audience. Okay, nobody please tell me in short how can you create a database of GIS? Okay, I think you're not present in previous class. What you have to do for geodatabase, I've also provide a tutorial. Hers, if you share the tutorial data today as well, because most of the students were absent yesterday, so they can access the tutorial in the data as well. So what you have to do, you know, for geodatabase, you have to go to our catalog and right click on your folder with wherever you want to save your database. Just right click on this folder. Let me create another geodatabase, create a new, and then go for file. If you have a lot of data, more than 2 GB data you are working with, so you can go for file geodatabase. If you have data smaller than 2 GB, then you can go for a personal geodatabase. Click on that, just rename it, and again click on this personal geodatabase, and you can make a feature data set in that geodatabase. You can also create a simple feature class in that geodatabase, but it would be good if you create a feature data set so that you have compiled data sets for your feature classes. I think it's a short answer for your question. Consider the yes, Haris will share a tutorial and the data today again. Haris, can you please share the data with the participants again?
The same tutorial which
Yes,
you
the
shared
same
today?
tutorial. Yes, I have shared yesterday a tutorial, but someone, I think most of the people are not able to, were not able to download it. So,
Okay, I'll share it again.
okay, thank you. Okay, Muhammad Ijazuddin has raised his hand. I think it's been the time. And Abrar Hussain, yes, you can ask your question. Abrar Hussain, unmute your mic and you can ask your question. IUMC boardroom, I think he has some question. Okay, and each product each data frame has its own scaling. Yes, is I have shown my map that let me share that again. That I have added 2 inset map, right? Okay, is now is I think it's visible to you guys. This map have this insert map has its own title, its own scale, and its own grids. Now another insert map has its own title and its own scale and its own grids as well. We don't need to give to put the north arrows in every data frame or any every insert map, but you have to do but only add only one north arrow to the main data frame. So that would be enough for your representation of north arrow in that map. So if you need it, if you need legends over here, but I think you are not supposed to be showing something in your insert map which have some legends. But still, if you have the map or you have the information in your insert map that must be represented by some legends, that some pictorial representation it needs. So yes, you can add legends as well, but scale and grids and title must the insert map must have the scale, its title, and its grid as well. Horace, I think this message is for you. That is, are you going to share the materials or registered emails? Unfortunately, I
Yes,
was
I'm just going to copy the file in the chat.
Okay.
Because it's not possible to send email to everyone individually.
Okay.
I've shared the tutorial file in the chat. All the participants can download it again. In case you are not able to download it, please let me know. We also have a question from a participant. There was a hand raised by Zahid.
If someone has a question, please unmute your mic and can ask your question.
Sorry, we don't have any chat group. This training is only for the registered participants, and all the information is being sent officially by emails if there is any change or anything else.
Yes, I think both files are the same because it is the same size. Files, both files are the same, I think.
That's the only file actually we have.
Okay, yes, we have shared this tutorial in data. Actually, you have shared it twice, so I think participants are confusing in that.
So I think it is okay for today, and we hope to see all the participants tomorrow again at 12 noon Pakistan time. Thank you, everyone. Thank you, Ms. Benazir, for a wonderful
Thank you.
presentation.
Thank
Thank you,
you.
participants. Thank you, everyone.
Thank you. Bye bye. Love, peace.